Astronomers have found more than 5,000 planets beyond our solar system. Most are unremarkable. A few shouldn't be possible. One planet is being stretched into an egg shape by its own star. It has maybe 10 million years left before it's gone. Another is darker than coal, swallowing almost every photon that touches it, while it glows red-hot from the inside. One may rain molten glass sideways, in wind moving at 8,700 kilometers per hour, and three more were never supposed to exist at all. They formed after their star already died. These are the most disturbing exoplanets we've ever discovered. 900 light-years out, a different planet holds a color that looks almost inviting from a distance, a deep, ocean-like blue, the kind early observers assumed had to mean water. For a while, that assumption held. Push a probe close enough, and the blue resolves into fine glass particles, suspended in an atmosphere that never cools. Surface heat holds near 930 degrees Celsius, hot enough to keep that glass forming and shattering in an endless cycle. Then the wind arrives, and the picture changes again. It moves at roughly 8,700 kilometers per hour, several times the speed of a rifle round, and it never slows, never shifts, never gives this planet a calm side to hide on. It carries the glass with it, sideways, permanently. There's no eye to this storm. There's no direction it isn't blowing. An entire planet, functioning as one continuous weapon, powered by nothing more exotic than heat and wind, held in place for longer than our species has existed. The planet orbits its star at a distance of roughly 4.7 million kilometers, close enough that a full year here lasts about 2 days. That closeness locks one side permanently facing the star, and the other permanently facing away. So there is no true sunrise or sunset anywhere on this world. Only a fixed line between blinding daylight and permanent dark. Hubble first confirmed the color in 2013, using changes in polarized light as the planet passed behind its star. The first time astronomers had ever measured the actual color of a world beyond our solar system. What came back wasn't the muted brown or gray typical of gas giants closer to home. It was a deep, saturated blue, more vivid than Earth's oceans look from orbit. None of that beauty survives contact. A raindrop of glass moving at those wind speeds wouldn't just sting on impact. At roughly 4 times the speed of sound, it would behave less like weather and more like grit fired from a sandblaster built at planetary scale, and it never lets up long enough for anything to recover between hits. This one announces exactly what it is. The next entry in the same catalog uses the same underlying physics to do the opposite and gave no warning at all. 750 light-years away, the first readings on a Jupiter-sized planet suggested nothing unusual. Dark, quiet, forgettable, one more gas giant in a growing list of them. Then someone checked how much light it reflects. Less than 1%. Darker than coal. Darker than fresh asphalt. Darker than anything humans have manufactured to absorb light on purpose. For a while, the numbers looked like an instrument fault. Nothing that dark should also be glowing with its own heat. And this planet was. Surface temperature near 980 degrees Celsius. Hot enough to radiate a faint red ember light into space. Astronomers reran the analysis more than once before accepting both readings were correct. Whatever is happening in its atmosphere isn't behaving the way astronomers expected. Eventually, the explanations surfaced. Light-absorbing compounds, high up, trapping nearly every photon that reaches them before any of it can escape back out. A world this massive, burning from the inside and still nearly invisible in ordinary light, not hidden because it's far away, but because its own atmosphere was built by pure chemistry, not to be seen. This planet orbits so close to its star, roughly 5 million kilometers out, that a year here lasts under 2.5 days. That proximity should make it one of the brighter objects in its system, reflecting a good share of the light constantly pouring onto it. Instead, the readings kept coming back the same way, as if the planet were actively refusing to bounce anything back at all. Researchers now suspect the culprit isn't one single compound, but several vaporized metals like sodium and potassium mixed with gaseous titanium oxide, all suspended high in an atmosphere hot enough to keep them from ever condensing into reflective clouds. The result behaves less like a planet and more like a specialized coating, the kind engineers spend years trying to manufacture in a lab, except this one assembled itself by accident out of ordinary starlight and heat. From Earth, telescopes never actually see this planet directly. They only know it exists because of the tiny, precise dip it causes in its star's light every time it crosses in front, a shadow with almost no other visible trace of the object casting it. Not every planet with something to hide manages it this well. Some run too hot to hide anything at all. Same 3 ingredients as before: heat, gravity, distance, just carried one step further. Roughly 670 light-years out, a planet holds the record for the hottest surface ever measured on a world outside our solar system. Dayside heat reaching 4,300 degrees Celsius. For years after its discovery, researchers weren't convinced an atmosphere could survive conditions like that at all. It can't, not in any ordinary sense. That heat is enough to tear hydrogen molecules apart into single atoms before they ever finish crossing into daylight. Those atoms drift to the planet's dark side, cool just long enough to bond back together, then get torn apart again on the next rotation. This isn't a planet losing its atmosphere once. It's a planet destroying and rebuilding its own atmosphere continuously every single day for as long as it survives, and it won't survive indefinitely. Its outer layers are already escaping into space, a visible trail streaming behind it like smoke pulled from a wound that never closes. This planet completes a full orbit in under a day and a half, locked so tightly to its star that one side never stops facing the heat. Its star isn't an ordinary yellow sun either. It's a blue-white star roughly twice as hot as our own, radiating far more ultraviolet and visible energy onto the planet below than any world in our solar system has ever had to withstand. Spectroscopic readings taken as the planet passes in front of its star have picked up something else: unmistakable traces of vaporized iron and titanium drifting through the upper atmosphere, metals that stay solid on Earth and only exist as gas here because nothing on this world stays cool enough, long enough to be anything else. Eventually, models suggest this won't matter. As the host star continues to evolve, it's expected to expand outward, and this planet sits close enough that engulfment isn't a distant hypothetical. The same heat currently tearing its atmosphere apart, atom by atom, is, on a longer time scale, also closing the distance between predator and prey. This star is still in the process of taking its planet apart, one atom at a time. Some stars already finished that process a long time ago and all at once. Something detonated roughly 1,000 light-years away, and by every model astronomers had at the time, nothing should have survived it. A massive star collapsed and exploded outward as a supernova, a blast that should sterilize or vaporize anything orbiting close enough to matter. That was the expectation in 1992, when instruments first pointed at what remained, a dense, rapidly spinning corpse of a star, barely the size of a city, spinning dozens of times per second, throwing out beams of radiation like a lighthouse built from something already dead. Then the readings kept returning a pattern that shouldn't exist. Something was still orbiting it, not once, 3 separate times at 3 separate distances, in rhythms too precise to be noise. 3 planets, roughly Earth-sized, circling the wreckage of a star that had already ended. Not planets that survived the explosion, planets that appear to have formed after it, assembled out of the very debris the blast threw outward, bathed, since the moment of their birth, in radiation lethal to anything alive. The discovery belonged to astronomers Alexander Wolszczan and Dale Frail, who first announced it in 1992, 3 years before the first exoplanet was ever confirmed around an ordinary, still-living star. That makes these 3 worlds, technically, the very first planets beyond our own solar system that anyone ever proved existed, found orbiting. The one kind of star nobody expected to have any left. They orbit at distances of roughly 0.19, 0.36, and 0.46 astronomical units, close enough that each completes a year in under half an Earth year, and their masses come out close to Earth's own, a detail that makes the resemblance almost unsettling given everything else about where they sit. When the public was later asked to help name them, the choices that came back weren't hopeful. Draga, Poltergeist, and Phobator, names borrowed from folklore about the restless dead and figures that haunt the living in sleep. Nobody intended that as a joke. It was simply the closest language anyone had for worlds that exist only because something else had already died around them. These worlds were never protected from destruction. They were built directly out of it. None of these worlds needed anything unusual to become what they are. Not a hidden force, not something we haven't discovered yet. Just heat, or gravity, or distance from a star, held in place long enough. A planet can be sandblasted by its own weather, hidden in plain sight by the same chemistry that keeps it glowing. Torn apart atom by atom in daylight, it can't escape, or formed from the wreckage of a star that already died, a planet whose origin and its destruction happened in the same moment. Different mechanisms, same outcome every time. Nothing that gets this close for this long stays intact. Earth sits at a distance, and a temperature and a gravity that none of these worlds got to keep. Not because it earned that stability, because it's still early in the same clock that has already run out for every planet on this list. We haven't found anything as stable as home yet. What we keep finding instead is everything home would eventually become if it ran out of time.